Okay, so 6.10 or 6.10 is about geothermal energy. So let's go ahead and jump into these notes. So, geothermal, some basics that you need to know about geothermal. First of all, there's natural radioactive decay of elements deep in Earth's core that gives off heat. We already know that. We talked about nuclear decay, and that when the nucleus of an radioactive element is decaying, that it'll give off energy, and that energy is given off in the form of heat. And so that is what drives magma convection currents, which carry heat to the upper portion of the mantle, close to the Earth's surface. So while I say this is close to the Earth's surface, it's still, potentially miles beneath the ground. And so we do have to mine or, put something pretty deep in the ground to harness this energy. Water can be piped down into the ground and heated by this heat from the mantle, but it has to be driven down pretty deep. It's not something that can just go down like a few feet, like a heat pump on a house. So if you have a heat pump on a house, it's not technically considered geothermal energy. That's something that's a little bit different. Geothermal energy is going to be the energy that's coming from the heat from that mantle. And so basically that hot water, what did I want to say about that is that geothermal energy is not necessarily being used for homes. It's being used more for industry as opposed to homes at this point. And so it'd be cool if we could use geothermal energy, maybe, for well, we do use it for if we could use it to like create like geothermal power plants that could, power entire cities, that would be a good use of geothermal basics. We're not actually using it for individual homes. I guess that's what I wanted to say about that. So hot water, then that hot water goes through the whole process that we used with like burning fossil fuels and creating electricity at power plants, where we convert that hot water into steam. The steam, that kinetic energy of the steam is used to turn the turbine. That turbine is used to turn that electrical generator, which then that electricity goes to a transformer, which is then pumped into the electric grid, and we can use that to heat homes directly. Okay. So that's how we can use geothermal to heat homes. We can also use geothermal for like that electrical production. And so natural heated water reservoirs underground are drilled into and then piped up to the surface, or that water can be piped down into naturally heated rock layers. One of those two things can happen. So either pump the hot water up or pump the water down and heat the water up. The heat from the magma turns the water into steam, and then that steam is then forced through pipes to spin that turbine. Water is also cooled just like in a fossil fuel plant or a nuclear plant. The water then has to be cooled because we have hot water. So it's usually just returned to the ground to start the process over again. This is a renewable form of heat since the Earth's core is not going to run out. When it does run out, we won't have life on the planet anymore. So that would be a real problem. But then it's only if the groundwater is returned after use. So that's why it's considered renewable. So if we take the water out of the ground and then put it back in the ground, that would be considered, that's when we consider it that renewable energy source. Okay. So ground source heat pump, when I was talking about that earlier, that's just a ground source heat pump. So usually the water only goes down about 10 feet. So that's not actually reaching like the heat from the mantle. The ground stays a consistent 50 to 60 degrees just from holding heat from holding the light energy from the sun. That's not actually warmed by geothermal energy from magma. So technically it's not that geothermal energy. That heat absorbing fluid is actually is pumped through a pipe into the ground where it takes on the heat from the ground, which again comes from the sun. Okay. And then in the summer, it's used to heat from um, the heat from the home transfers to that liquid, and the liquid transfers the heat to the ground, which is cooling the house. And in the winter, the liquid takes heat from the ground that was there from the sun's energy and transfers it into the house that's warming the house. And so that's how heat pumps work. So if you happen to have a heat pump on your house and they call it geothermal energy, that's actually a misconception. It's not. true geothermal energy involves that piping that water deep into the ground. It's different than the ground source heat pump. The well has to go thousands of meters or kilometers down into the ground to reach the heated water reservoir below ground. So that's why it's used on an industrial scale and not on an individual home scale. The heated water is then piped up, like we said before. So, what are some pros? It is renewable if the water's piped back into the ground, because then we're just consistently keeping that cycle going. Much less CO2 emission than fossil fuel electricity. We do have to have energy pumping the water and then drilling for that initial pipe into the ground. That's going to take some energy. There's no release of particulate matter, SOxes, NOxes, or CO, carbon monoxide, or CO2, other than the CO2 that we need to do the pumping. So there's none of that other gases, as are the case with fossil fuels. And then there are some cons. Not everywhere on Earth has access to geothermal energy. I mean, we can reach the we can't, because I guess what I want to say is, the mantle is everywhere on the planet. But because of the how much ground we would have to actually drill through, it's not accessible everywhere. So it has to be close enough to the surface for us to get to it. And so that's the issue with using geothermal. And so you can see here in red, the temperatures at 7.5 kilometers in the ground. So 7,500 meters in the ground. The ground temperatures get pretty warm, enough to boil water. And you can see where this like red areas are would be ideal for using geothermal. Okay. Hydrogen sulfide is something that can be released, which is toxic and can be lethal to humans and animals in the process of drilling this far into the ground. And then the cost of drilling that deep is very high initially. So that's a con. Sometimes it's so high that it's just not worth actually going through with that process. So that's the deal with geothermal. It can't be readily used like a heat pump. That's not geothermal. Okay. All right. So practice FRQ 6.10. Identify the source of initial energy in geothermal power generation and explain how these systems can be used to generate electricity. That's it for geothermal. And next time we're going to be talking about hydrogen fuel cells. We're almost done with Unit 6, and I'll see you guys soon.